Hello farmmates, did you know that everything around us is made up of the elements? So today we're going to look about the group 1A of the periodic table, or also known as the alkali metals. Alkali metals are composed of lithium, sodium, potassium, rubidium, cesium, and more recently francium. They are soft, shiny, and low melting point, most reactive element, a very good reducing agent, and they are found in the nature as a free element but generally as salts. Although hydrogen is not an alkali metal itself, it has some similar properties due to its simple one proton, one electron arrangement. Hydrogen is the first element in the periodic table. It's the simplest possible atom composed of one proton and the nucleus, which is orbited by a single electron. Hydrogen is the lightest in the elements and the most abundant element in the universe.
How it was discovered. English scientist Henry Cavendish discovered hydrogen as an element in 1766. Cavendish ran an experiment using zinc and hydrochloric acid. He discovered hydrogen and also found that it produced water when it burned. It is used to make ammonia for fertilizers, refining metals, and methanols for making artificial material like plastics. Hydrogen is also used as a rocket fuel, where liquid hydrogen is combined with liquid oxygen to produce a powerful explosion. Hydrogen has isotopes, and these are the protium, which is the most abundant, the deuterium, which is the heavy hydrogen and manufactured in batteries, and the tritium, which is the radioactive.
Lithium is the lightest known metal that can also lighten your mood. It has the atomic number 3, atomic symbol Li, and atomic weight 7, and has a boiling point of 1342 degrees Celsius.
Informations about lithium. Lithium-ion batteries are the key to lightweight, rechargeable power for laptops, phones, and other digital devices. The United States has one lithium mine in Nevada, according to the USGS. Chile and Australia produce the most lithium in the world. Naturally occurring lithium in drinking water correlates with lower levels of suicide, according to a 2009 study that highlights lithium's role in the brain. On a lighter note, the element is part of celebratory fireworks shows. A mix of lithium and strontium salts, along with some other chemicals, creates the show's brilliant red color. Lithium is a special metal in many ways. It's light and soft, so soft that it can be cut with a kitchen knife, and so low in density that it floats on water. It's also solid at a wide range of temperatures, with one of the lowest melting points of all metals and a high boiling point. A Brazilian naturalist and statesman, José Bonifácio de Andrade e Silva, discovered the mineral petalite on the Swedish isle Uto in the 1790s. According to the Royal Society of Chemistry, or RSC, the mineral is white to gray, but when thrown into fire it flares bright crimson. In 1817, Swedish chemist Johann August Arfwedson discovered the petalite contained a previously unknown element. He wasn't able to isolate the metal entirely, but he did isolate one of its salts. The name, lithium, comes from lithos, the Greek word for stone. It took until 1855 for someone to isolate lithium. British chemist Augustus Mathiassen and German chemist Robert Bunsen ran a current through lithium chloride to separate the element. Lithium is an element of many uses. It's used in the manufacture of aircraft and in certain batteries. It's also used in mental health. Lithium carbonate is a common treatment of bipolar disorder, helping to stabilize wild mood swings caused by the illness. Lithium makes up a mere 0.0007% of the Earth's crust, according to the Jefferson Lab, and it's only found locked up in mineral and salts. Those salts have the power to change the brain. Lithium salts were the first drugs approved by the Food and Drug Administration to treat mania and depression, according to the National Institute of Mental Health. Today, lithium carbonate is the compound most often sold as a pharmaceutical. No one knows exactly how lithium works to stabilize mood. Studies show multiple effects on the nervous system. The findings, which would need to be replicated in humans, suggest the element silences certain neurons in the brain and may have a calming effect. Lithium affects the flow of sodium through nerve and muscle cells in the body. Sodium affects excitation or mania. Lithium is used to treat the manic episodes of bipolar disorder or manic depression. Lithium also helps to prevent or lessen the intensity of manic episodes. Important informations. Do not use lithium without telling your doctor if you are pregnant. It could cause harm to the unborn baby. Lithium toxicity can cause death. Here are the symptoms of lithium toxicity: muscle weakness, twitching, drowsiness, feeling lightheaded, mood changes, blurred vision, ringing in your ears, irregular heartbeats, confusion, slurred speech, clumsiness, trouble breathing, or seizures. Lithium can cause side effects that may impair your thinking or reaction. Before taking this medicine, you should not use lithium if you are allergic to it. Some medicines can interact with lithium and cause a serious condition called serotonin syndrome. Lithium is not approved for use by anyone younger than 7 years old. Early signs of toxicity include vomiting, diarrhea, drowsiness, muscle weakness, or loss of coordination.
Sodium was discovered in 1807 by Sir Humphrey Davy. The word sodium came from the word soda.
We can get all the sodium we need from our food without adding any extra. The average person eats at least 10 grams of salt per day, but all we really need is 3 grams. Any excess sodium may contribute to high blood pressure. Sodium is important for many different functions of the human body. For example, it helps cells to transmit nerve signals and regulate water levels in tissues and blood. Sodium is the sixth most common element on Earth. It makes up 2.6% of the Earth's crust. The most common compound is sodium chloride or NaCl. This very soluble salt. Because sodium is so reactive, it is never found as the metal in nature. Sodium is used as a heat exchanger in some nuclear reactors and as a reagent in the chemical industry. But sodium salts have more uses than the metal itself. It is also an important constituent of a number of silicate materials such as feldspars and micas. Sodium is by far the most commercially important alkali metal. Most processes for the production of sodium involve the electrolysis of molten sodium chloride. Inexpensive and available in tank car quantities, the element is used to produce gasoline additives, polymers such as nylon and synthetic rubber, and a number of metals such as tantalum, titanium, and silicon. Sodium chloride or salt was used as a flavoring and preservative and is used to de-ice roads in winter. Salt is the most common form of sodium, which forms the mineral halite, and it came from seawater. Soda came from the Natron Valley in Egypt or from the ash of certain plants. Most of the world's supply of sodium carbonate is derived from processing trona ore. Their composition was debated by early chemists, and the solution finally came from the Royal Institution in London in October 1807, where Sir Humphrey Davy exposed caustic soda or sodium hydroxide to an electric current and obtained globules of sodium metal, just as he had previously done for potassium, although he needed to use a stronger current. The following year, Louis Joseph Gay-Lussac and Louis Jacques Stennard obtained sodium by heating to red heat a mixture of caustic soda and iron filings. Lighter than water, sodium can be cut with a knife at room temperature, but is brittle in low temperatures. It conducts heat and electricity easily and exhibits the photoelectric effect, which is the emission of electrons when exposed to light to a marked degree. Sodium is essential to all living things, and humans have known this since prehistoric times. Our bodies alone contain about 100 grams, but we are constantly losing sodium in different ways, so we need to replace it. It is a soft, silvery white metal that tarnishes within seconds of being exposed to the air. It also reacts vigorously with water. This very soluble salt has been leached into the oceans over the lifetime of the planet, but many salt beds are found where ancient seas have evaporated. It is also found in many minerals, including cryolite, zeolite, and sodalite, a market that disappeared with the advent of unleaded gasoline. The earliest uses of metallic sodium were in the manufacture of sodium cyanide and sodium peroxide. Significant quantities were used in the manufacture of tetraethyl lead as a gasoline additive, a market that disappeared with the advent of unleaded gasoline. Substantial amounts of sodium are used in the manufacture of sodium alkyl sulfates as the principal ingredient in synthetic detergents. Sodium carbonate or soda was used for glass manufacture and as a water softener.
Potassium is the fourth element present in Group 1A, and it was discovered by Sir Humphrey Davy in 1807 in England.
Potassium appears to be violet under flame test, predominant intracellular cation. It has three main sources, which are sylvite, potassium chloride, carinolite, potassium magnesium chloride, alunite, potassium aluminum sulfate. Potassium support blood pressure, cardiovascular health, bone strength, and muscle strength. Beet, greens, white beans, soybeans, and lima beans are the food highest in potassium. Potassium was isolated in 1807 by Sir Humphrey Davy, who obtained it through the electrolysis of very dry molten caustic potash, potassium collected at the cathode. Potassium was the first metal isolated by electrolysis. Davy isolated sodium by a similar procedure later in 1807. Potassium deficiency can lead to fatigue, weakness, and constipation. It can escalate to paralysis, respiratory failure, and painful gut obstructions. Potassium is effective for low levels of potassium in the blood or hypokalemia. Taking potassium by mouth or intravenously prevents and treats low levels of potassium in the blood. Potassium is likely safe when obtained from the diet in amounts of 40 to 80 milliequivalents per day. Taking too much potassium is unsafe during pregnancy and breastfeeding.
Rubidium was first discovered in 1861 in Heidelberg, Germany, by Robert Bunsen and Gustav Kirchhoff.
Rubidium is a silvery white and soft metallic element. Its main source is lepidolite. It is commonly solid at room temperature, but can easily melt at 39.3 degrees Celsius. Rubidium can ignite spontaneously in air. That's why it needs to be submerged with kerosene. By doing a flame test, it has a color of reddish violet. And lastly, it is not known to be toxic to our body. Let's move on to the uses of rubidium. First, it is used in photocells as a getter or remover of trace gases in vacuum tubes. It is used in atomic clocks. Rubidium salts are used for special glasses and ceramics. Rubidium compounds give a purple color in fireworks.
Discovered in 1860, also by Robert Bunsen and Gustav Kirchhoff. It was also
Cesium is a silvery gold, soft and ductile alkali metal, which is liquid in a warm room, and melts at a temperature of 28.4 degrees Celsius. It is known to be one of the few metals that are liquid near to room temperature, and is the most reactive metal in Group 1A. Cesium must be kept under inert gas, or liquid, or in a vacuum to protect it from air and water. It is also considered to be mildly toxic. Main sources are polysite and lepidolite. Uses of cesium are the following. Like rubidium, it also serves as a getter in vacuum tubes and used for atomic clocks. Used as a catalyst in hydrogenation of organic compounds. And cesium hydroxide is used for etching silicon.
How it was discovered. French chemist Marguerite Catherine Paris discovered francium in 1939 at the Curie Institute in Paris, but its existence was predicted by Mendeleev during the 1870s. Since its properties should track those of cesium rather closely, he called it ecacesium. Since francium is produced in tiny quantities in nature, it does show any much commercial applications. It has been used in the field of research, chemistry, and also in the atomic structure, diagnostics for curing cancers, and it is also used in many spectroscopic experiments. Francium is a highly radioactive metal, and since it exhibits a short half-life, it does not have more impact on the environment.